Background: cocoa butter is manufactured as the main byproduct from dry, fermented cocoa beans. The biochemical composition of this cocoa byproduct: scouse triacylglycerols, D and monoglycerides, phospholipids, and glycolipids, and unsaponifiable matter. During primary post-harvest processing, cocoa beans harbor lipase-producing mold species contamination could trigger the accumulation of FFA. High free fatty acids, FFA, content of dry fermented cocoa beans currently alter physical properties of both fat fraction and chocolate. Aims: this study investigated the improvement of the quality of raw cocoa material sourced from Côte d'Ivoire regarding its FFA concentration. Methods: 50 dry fermented cocoa beans samples were randomly collected during October 2018 from Aniashu, Aku, and Yakassayatobrau, 3 big cocoa producing regions located in southeast of Côte d'Ivoire. Dry fermented cocoa beans were sampled on farm level in the same cocoa producing region. Contaminating filamentous fungi strains were isolated using Sabarod chloramphenicol agar incubated at 25 degrees Celsius for 7 days. Morphological identification of fungi isolates was performed from younger culture. Biochemical study for the determination of lipolytic properties of fungi was carried out using Caspectox agar medium enriched with olive oil as carbon source and rhodamine B as indicator of extracellular lipase production. Extraction: PCR amplification using a specific transcribed spacer primer, its 5, and sequencing of DNA from fungal species were performed for molecular identification. Results: approximately 154 fungal isolates belonging to 8 genera were found in tested cocoa beans sourced from Côte d'Ivoire. Only Rhizopus oryzae, Apsidia, Corymbifera, Mucor himalis, Aspergillus niger, Aspergillus tubangensis, Aspergillus aculeatus, Aspergillus flavus, Aspergillus tamari, Aspergillus fumigatus, Nigrospora spherica, Curvularia geniculate, and Penicillium. Chrysogenum species exhibited greater extracellular lipase producing ability. Apsidia corymbifera, Aspergillus niger, Aspergillus fumigatus, and Rhizopus oryzae were mostly frequent and predominant species contaminated Ivorian cocoa beans. Dry fermented cocoa beans inoculated with Rhizopus oryzae, Apsidia corymbifera, or Aspergillus niger recorded higher FFA content above 1.75%. Conclusion: reducing of the growth of the fungi species growth during cocoa. Primary post-harvest processing could sustainably produce raw cocoa material with less FFA content. This study clearly indicated that the control of lipolytic fungi contamination in dry fermented cocoa beans could reduce FFA content and sustainably improve the quality of cocoa beans sourced from Côte d'Ivoire, cocoa, butter and chocolate produced thereof.